Hello, everyone. I'm Elena. I'm a software engineer from a Go platform team at Uber. And today I'm super excited to share our story how Uber goes. So let's start from the beginning. It was 2015, and as many startups, Uber started very simple. We had just a few services, few engineers, very simple infrastructure. And at that time, we thought that all we need to build fast and to grow fast, we need new features in our application. We thought we don't need complex solutions or sophisticated tools, we just don't have time for this. So that's what we did. We started to introduce new features, to add new services. We started to grow. And then it just happened. In a year, we already had hundreds and hundreds of services and hundreds of engineers in our code base. We got a lot of new features. That's great. We also got inconsistency in our code base. Everything was different. All services were unique. And very soon after that, we realized that we have some productivity problems. Basically, it was hard for our engineers to be productive in this environment. Even simple tasks took a lot of time and effort. For example, creation of new services. What does it mean to create a new service? It's really hard to say what we can reuse with given code base, right? For example, how should I structure my code? One way, maybe another, who knows? What library I should use? This one, or maybe that one? Again, it's hard to say. What version of the library? There are so many options. Maybe I can use this one, maybe I can use that one. Actually, I like this one. Let's use this one, because why not? As a result, it took a while to figure out what to use, how to use, and now we have yet another different service, inconsistent with everything else. And here's another example of productivity problem, context switching. What if now I need to work on a new service, which I have never seen before? How much time could it take for me to figure out new structure, new libraries, new names, how to run it, how to test it? It took a lot of time, every time, when our engineers needed to work on a new project. And final example, delivery of global features. What if now we want to deliver a feature to all services? Even if it's a same change, it's still yet different change every time for every service, because all of them are so different. And again, it took a lot of time. And there are a lot of different ways to approach this problem. I just want to tell our story, what we tried at Uber, and specifically I want to talk about three most interesting things from our perspective: dependency injection, consistent code structure, and monorepo. Let's talk about dependency injection first. Specifically, let's talk about creation of new services if we don't have dependency injection, and then we can compare it with dependency injection approach. So what does it mean to create a new service? Basically, it means we need to write some Go code, right? But if we don't have frameworks, if we don't have dependency injection, that means that we also need to write some extra code and spend some extra time to write something which we not really need for our service specifically, but still it is important and needed. For example, some basic things like logger, right? Everybody needs logger. Which means that, let's keep it simple example, just standard logger. Just a few lines. And here's block of code which is responsible for my logger object, right? What else do I need to write? Maybe configuration. Again, for any service, we need some configuration. So let's write just a few more lines to create my configuration. Here's block of code for this. What else? Maybe server, because probably we need a server, right? Let's write again just one more line. Here's a block of code for my server. What else? Well, there are a lot of things, like, for example, rate limits, health check, environment variable, different debug endpoints, stats, and so on and so on. I'm not going to list all of them, but believe it or not, there are so many different things. This is essentially our main function. And sometimes we had hundreds, sometimes 1,000 lines of code in our main functions. So it took a while to write this long main function, a lot of code, but now we are done, almost. What if Now there is a new requirement, for example. We need to add tracer to our servers. What does it mean for me? Again, let's keep it simple, just a 2-line change. I need to create a tracer object, and then I can use it in my server. So basically, in my code, it means that I need to find the right place for my first line, where to create a tracer. And if my tracer depends on logger and config, that means I need to insert this line after logger and config, basically, right? So I insert this new line here, and then I can use this in my server. And I have traces now. That's great. I'm done. I'm happy. But what about other services? There are hundreds and hundreds of other services, and all of them need tracer. So how can I introduce this 2-line of code to all of them, especially if all of them are different? Different names, different order, different libraries. What should I do? Well, I can go to Slack, for example, and just ask everybody, hey, here, Uber, let's add tracer. I just did it. It was very simple, just 2 lines. I can even copy and paste these 2 lines and provide them. You can do it too. But is it going to work? Because what if, for example, another service, maybe they use same logger but different configuration, and maybe different server, maybe both. That means that they need to adjust this solution, right? They can't just copy and paste my 2 lines. It is not going to work. It requires some extra work, right? Which means extra time, which is not great. And maybe sometimes we have to rewrite the entire main function only because of this simple change, which is, again, it took a lot of time. And that's why we decided to think, like, maybe there is a better solution for this. And actually, the solution is well known for problems like this. It's a dependency injection. Because with dependency injection, we don't need to create objects. We don't need to worry what to create first, how to create second object, and so on and so on. We can just ask dependency injection framework. And framework will create everything for us. And we can just grab and go what we need and use it immediately. So let's see how it works. We can create dependency injection container and provide objects, constructors for needed objects to this container. For example, if we need a logger, we provide constructor how to create logger. So now my dependency injection container knows how to create logger for me. We can provide configuration, server. We can even combine needed objects in one module, in one library. Let's call it defaults, for example, because by default, I want to provide this logger, config, and server. And in this case, we can write code something like this. Dependency injection framework, let's create new application, provide it with defaults, and run it. That's it. Just 3 lines, and this is my main function now. Very simple, very short, and plus all main function now look the same if all services use this dependency injection framework. Which means that now, same problem. If I want a tracer, I need to make this change in one place in this dependency injection container, provide my constructor, and I need to change my server again in order to use this tracer in one place. And that's it. Now I'm done, but I'm done for all services who use this dependency injection defaults module. Because now all of them use the same server, which is provided by defaults module, right? And if they need traces for their request, that means that they don't need to do anything. Dependency injection container will do all the work. It will find constructor, how to create a server. It will try to create a server and creates all dependencies. We need to create tracer. Tracer needs logger and config, so let's create logger and config. Let's pass them into a tracer, create a tracer, pass it into a server, and here you are, your server, ready to use object with traces now. And it works for everybody now, just like magic. You don't need to do anything, you don't need to change code, it just works. Now you have traces for your service. That's great. And that's what we do at Uber. We use our application framework, FX. And for this defaults library, we use UberFX module. which provides bare minimum functionality required for all Go services at Uber. And this functionality, all those objects already integrated with Uber's infrastructure. So it just works out of the box with zero configuration. And all we need to do is to write this code. So UberFX contains our solutions for configuration, logger, tracing, metrics, rate limits, etc., etc. And for our services, we can write main function like fx, new application fx. Let's import UberFX module and run this application. And that's it. It just works. We can immediately start working on a real code. We don't need to create any objects. They will be provided. So now let's talk about this rest of the code, the consistent code structure. And specifically, let's talk about context switching if we don't have consistent code structure, because at the beginning, we didn't really think about it, and we didn't have consistency in our code structure. So what does it mean if I need to work on a new service, which I have never seen before? All I know is that it receives REST requests. And my task is to migrate it to gRPC. So now I need to receive gRPC requests. What should I do? How can I make this change? Well, it's hard to say, because if I don't know structure, I know nothing about this service, that means that I need to learn how this service works, what it does, how to run it, how to test it, and then I can make a change. And maybe, because structure is unknown, I will have to rewrite the entire service, only because of this simple infrastructure change, new requirements, which is not great, and it took a lot of time to rewrite the entire service. And there are hundreds and hundreds of other services, and all of them are different. So every time when we need to work on a new service, new project, same story. I need to learn everything to find out what to change and how to change. And that's why we decided to provide a consistent code structure. Because if we have consistency, it should be much easier and very straightforward. For example, same task. Service receives REST requests, but now there is a transport layer where we abstract away code which is responsible for receiving requests from the rest of the code, business logic. In this case, all I need to do is to change this thin transport layer. And I don't really need to learn how this service works, what it does, what's inside this business logic, right? Which is much easier, and it doesn't take so much time. And we internally call these transport layer handlers. Handlers contain different handlers, REST, gRPC, and so on. And for business logic, the rest of the code, we use name controllers. And handlers talk to controllers with special structs, which contain information extracted from requests. For example, if there is a HTTP request, it goes to REST handler. For gRPC, it's a protobuf request, but in both cases, we extract information, for example, get trip request information, and store it in get trip request struct, and pass it into a controller. So in this case, from my controller perspective, it doesn't really matter how we got this information, via gRPC, REST. Either way, it's a get trip request, same struct. And that's how we abstract away transport layer, our handlers, from the rest of the code, but also we can abstract away how we store information. We internally call it repositories, and we also can abstract away how we talk to external services. We call it gateways. So let's talk about repositories for a second. For example, for my controller, I need a storage for users and trips. In this case, I have two repositories for users and trips, even if both of them use MySQL as a storage, for example. And it might be any database, DynamoDB, Redis cache, doesn't really matter. And if, for example, now I use MySQL to get list of users, I call my repository with get list users request struct. And in my repository code, in my user repository, I have this implementation for MySQL. But if I need to migrate to Cassandra, for example, I change implementation of my user repository, and then I can use new implementation without changing anything in the controller, in the rest of the code. It still works it still calls the same repository with the same list user request. So it means that I need to change much smaller code, basically. Gateways are very similar, except that they are scoped to a service which we are talking to. For example, if I need to make a payment, there is a payment gateway. For emails, there is an email gateway. And if, for example, I need to charge payment, I call gateway from controller with charge payment request. And then there is implementation for this service specifically. For example, it might be HTTP request. If they change their API or require some changes, now, for example, I need to send a protobuf request. That means that I need to change implementation for this gateway, but I don't need to change anything else. I need to migrate to new implementation, and my controller is still the same. I don't really need to learn how it works, and I don't need to change anything there, which is great. And that's the structure which we decided to use. And this is very convenient because if I need now to receive new requests, for example, GraphQL requests, all I need to do is to add new handler. If I need to migrate my user storage from MySQL to Cassandra, again, all I need to do to change only this small piece of the code. If I need to change payment, communication with payment service, again, it's just a small change. And especially, this is nice because I don't need to change business logic. The core of the service, it still works. It's still protected from unneeded changes, which are not directly related to my business logic. And that's a structure which we decided to provide for all our services. But we not only decided to recommend this structure, we built tools to enforce this structure. We internally call it Glue. This is our internal tools, which was inspired by clean architecture. And the idea is to keep your code clean from unneeded information, not directly related to your service. If it's a business logic, it's a pure business logic without database statements, different requests, and so on. And we even built additional tools. For example, we have a command line tool to generate project structure for us. We can run one command, and we will have our controller, gateway, handler, repository. We only need to fill our implementation. And structure is already provided. Plus, we can generate additional things, like we can generate mocks for our unit tests, and lots of interesting things for observability, like, for example, metrics or dashboards. And this is super nice when you don't need to do anything, but you have dashboards and metrics by default out of the box. And that's how we structure our code. Let's talk about whole picture now. Let's talk about monorepo. Specifically, let's talk about delivery of global features. If we don't have a monorepo, and then we can compare it with monorepo approach. So what we have so far, we have our very small, simple main functions. We have very well-structured code. And this is my service now, right? But also, most of the time, we use some libraries. Like, for example, we at Uber use UberFX. So that means that this service depends on this library. So there is a dependency component inside. And before monorepo, we had polyrepos. Each service was in a separate repository. Except that this was very hard, almost impossible, to make sure that even if there is the same library for everybody, everybody uses the same version of this library. Because maybe someone uses latest version. But maybe someone decided not to update their dependencies today. Maybe someone haven't updated this version for a few weeks or maybe even months, and they are now like hundreds of commits behind. But what if now there is a new feature or maybe even security fix, very important, very critical. Now everybody must update version of this library. How can we do this? Well, I know I can go to Slack again and just ask everybody. This is very urgent, update please, but is it going to work? Because if I use latest version and I know about this security fix, I can update my version, maybe someone else updated, but if we haven't updated for weeks or even months, even if we try to update, we will have breaking changes, most likely, right? Because when you are hundreds of commits behind, be ready to fix breaking changes. And what does it mean to update everybody now? How much time could it take to make hundreds or maybe thousands of commits across thousands of services, thousands of repositories. If some of them are maybe simple, just update dependencies, but some require fix and breaking changes, it might take a lot of time, right? And that's why we decided to build a monorepo. Because with monorepo, delivery of global features is much, much easier and doesn't take so much time and effort. All code with monorepo stored in one repository for services, for libraries, which means that if I need to make a change in my library, I change it for everybody at the same time. Everybody always uses the same code, same version. There is no version, basically. It's just the latest code in this repository. And plus, I can use build systems like we use Bazel to test that all applications work. If there is a break and change, I need to fix it immediately for everybody in order to make this change. And only then I can make this one commit, and it just works for everybody. So it definitely doesn't take so much time compared to thousands of engineers work on their breaking changes and try to fix them. Now it's just the responsibility of one team, maybe even one engineer, and it's just one commit. And that's why we decided to adopt dependency injection and to enforce consistent code structure. Now we are building a monorepo because it helps us to move our code base from inconsistency everywhere to very consistent state where everything is much easier and faster. For example, creation of new services. It doesn't take so much time anymore because we know exactly how new service should look like, what libraries we should use. We can even use code generation and just create a new service immediately. Context switching. Again, it doesn't take so much time because everything looks the same and you know exactly where to look for things which you need to change. And finally, delivery of global features. Again, it's much easier because with dependency injection, I can make a change in one place, and with monorepo, I can deliver it to everybody in one commit and one go, just like this. And it just works. And that's how we can be more efficient, because efficiency at scale is important. The more services you have, the more engineers work in your code base, the more crucial it is to be able to make simple changes fast. And now, based on our experience, we believe that efficiency at scale is based on consistency. This is very important. And the earlier you start thinking about consistency, the easier it is to achieve this consistency. So if you're a small startup and if you think, oh, maybe I don't have time and resources for this, maybe it's the best time to start thinking about consistency. And only one thing I want to add here, that we at Uber love Go. Now we have about 1,500 Go microservices in our code base and about 20 million lines of Go code. And we are still growing every day with more and more. And now we recommend Go as a backend programming language for all backend services at Uber. So now Go is the most popular programming language at Uber. Thank you so much. Huge thanks for Maria Leta for her awesome Gophers. Many, many thanks for my team for helping me to learn a lot. And of course, thanks to all of you for having me here. Thank you.